So, the objectives for today are to multiply radical expressions. So we're multiplying radical expressions. Today, we're going to talk about radical times a radical. We're also going to talk about a radical times an expression. So what do you think we might use there? A radical times an expression. What property? The distributive property. So in parentheses, distributive. So once we've got that written down, flip on over to page 63. And at the top, multiplying radical expressions. Page 63. So multiplying radical expressions. So just like always, we're going to have steps that we're going to follow that we can use as a resource during our homework and studying for our tests. So our first step that we're going to follow is to multiply the coefficients. So we're going to multiply the coefficients if there are any. That is our first step. Our second step will be to multiply the radicands. That's blurry. There we go. So, step 1, multiply the coefficients. Step 2, multiply the radicands. What is the radicand?
Base.
Greta. The number underneath the radical symbol. Very good. So, multiply coefficients, multiply the radicands, and now this looks like a problem we've already done. So, simplify the radicand is the third step. So we got 3 simple steps using multiplication and simplification. So we're going to multiply coefficients, multiply radicands, simplify the radicand. Let's look at a couple examples. Let's say we had the square root of 3 times the square root of 6. Square root of 3 times the square root of 6. Caleb. So we have the square root of 18. How did you get there? Why did you do that? Because it's what the rules say, but aside from the fact that's what the rules say. Brady.
Because coefficients are 1, so they would have to multiply them.
So we multiply the coefficients, which are 1. Kayla, you were wrong. Don't worry. So you have to multiply the coefficients and multiply the radicands. So the coefficients happen to be 1. And the radicands were 3 and 6. So 3 times 6 gave us 18. And now we have a problem that looks like what we've been doing. So this equals the square root of 18. Does that look like something we did last night?
Yes.
Yes. Square root of 18 can be simplified to what? 9 and 2. 9 is perfect, giving us a pair of 3's. So 3 square root of 2 is our answer. Simple enough, right? Let's look at another example. Let's say we had square root of 8x times the square root of 4x. What is that going to look like? What are our coefficients? Zach? Our coefficients are 1 and 1. What are our radicands? 8x and 4x. So what do we need to do? So we multiply 8x and 4x. That gives us what?
32x.
What's
Squared.
32x squared. So once again, we get a problem that looks like something we did last night. So we have the square root of 32x squared. How can we simplify 32x squared? What perfect number is in 16?
8.
8 and 4 or 2 and 16. Both work. 16 is just a little bit prettier. 16 gives us a pair of 4's. What about that x squared? X and x. We have a pair. So we have a pair of 4's and a pair of x's. So we pull out 4x. What's left? Square root of 2. That's our answer. No. What if they don't have the same index? Algebra 2. But what do you think? So if you had the cube root of something, you'd need 3 instead of 2 to circle, right? But that's high school. But good question. How about if we had 5 square root of 3 squared? So if we have 5 square root of 3 squared, what's another way to rewrite 5 square root of 3? We can do 5 square root of 3 times 5 square root of 3, and then that looks like a problem we can do, right? So we're going to go ahead and rewrite it as 5 square root of 3 times 5 square root of 3. And now we have something we can follow our rules with, right? What are our coefficients? 5 and 5, so we multiply our coefficients. So 5 times 5 is 20, or 5 times 5 is 25. Now we multiply our radicands. 3 times 3 is? And we have the square root of 9. 9's perfect. Good, Jonathan. We have 25 times 3, as Jonathan said, 75. So 25 times 3 is 75. Where did I get that 3 from? So we have 25 times the square root of 9. What's the square root of 9? 3. So 25 times the square root of 9 turns into 25 times 3, giving us 75. What if we had, let's say, square root of 3n times the square root of 4n squared times the square root of 12n? Do we have any coefficients? Just ones. They're imaginary. You don't have to put them. What are our radicands? We have 3n, 4n squared, and 12n. So what do we do with those? So 3 times 4 is? Times 12 is? 144. N times n squared? cubed times n to the fourth. So what does that leave us with? Gives us 144 n to the fourth. So we had 3 times 4 and n squared times n. That gave us 12n cubed times 12n. And as we said, 144 n to the fourth. Are we still good? You need more explanation? Or are we following pretty well? Joel?
On that one, you simplified it to 12 and squared.
Yes, you can simplify that to 12n squared. Why is that, Joel?
Because both 144 and n to the fourth are perfect squares.
Both 144 and n to the fourth are perfect squares. Very good. So we can simplify that down to 12n squared. Let's say we had a problem that looked like this one. Square root of 2 times square root of 12 plus 5. So now we have one that is different from all the other ones that we've had so far. Zach, what do you think we're going to do? We're going to distribute. So what's that going to look like? So we have the 2 times 12, that's a radicand, right?
Oh,
So it'll be 1 times 5. And then we'll have square root of 2. Because when we're multiplying base numbers that don't have radicals, all we have to do is put 5 square root of 2. Because there's no square root, there's no radicand to multiply by, right? So we're just going to multiply our coefficients. So we're going to distribute that square root of 2. So square root of 2 times square root of 12 is square root of 24. Square root of 2 times 5 is 5 square root of 2. Can we simplify 24? To what? 12 and 2 works. 6 and 2. 3 and 2. We have a pair there. 3 and 2 are prime. Nothing else we can do to them. So we leave square root of 6 in the radical. We pull out a 2. And square root of 2 is already prime. And there's our answer. Do we understand the distribution complex? So let's look at another one. And then we'll do a couple homework problems on the board. And you guys will come up and show us how to do them. So, one last one. We have the square root of 3 times the square root of 4 minus the square root of 5. So we have 3 square root of 3 times the square root of 4 minus the square root of 5. So what are we going to do? Braden. We're going to distribute. So square root of 3 times square root of 4 is square root of 12. Square root of 3 times the square root of 5 is square root of 15. So now we have the square root of 12 minus the square root of 15. Can we simplify 12? 4 and 3 is the nice one. And there we have a pair of 2. So we have 2 square root of 3. What about this 15?
5 and 3.
5 and 3. Can we do anything to that? So what do you think that means? We just leave it as minus the square root of 15. And there is the answer. So we're using our knowledge that we had before simplifying radicals. And now all we're doing is multiplying 2 numbers together and simplifying from there. So that is our notes. Our homework is posted on Google Classroom. I will